Hello and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 3, Lesson 1 on ratios. There is hardly a concept in math that is more important than that of the ratio. All right, so even though you've seen them both in 5th and 6th grade, we want to really kind of dig into some ratio work today, remind you of what they mean, what you can do with them, the kinds of problems that arise with ratios in them, because they're really the basis of so much in mathematics, including the graphs and equations of lines, including work that you do on percentages, as well as just straight up ratio work. All right, so let's get into it in the first exercise with a nice kind of review of a lot of basic ratio ideas. Here we go. Ratios tell us how much of one quantity we have compared to per another quantity. They can be scaled up or down using multiplication or division. All right? So let's take a look at what that per means and the scaling and all of that in the first exercise. A large fruit basket contains 21 apples and 14 oranges. Letter A asks us, what is the ratio of apples to oranges in simplest form? Use a fraction to help think about this problem. All right, fractions are used all the time with ratios because fractions, remember, you can multiply the numerator and the denominator by the same number, right? And that will give you an equivalent fraction. So we like to use fractions a lot when we think about ratios. It's a natural kind of device to use. Now, we see this, right? Large fruit basket contains 21 apples and 14 oranges. We want to know the ratio of apples to oranges. Apples to oranges. So we're going to see that phrase quite a bit, where we have ratio, apples, that word's important, to oranges. All right. Now, when we set up a fraction to represent a ratio in this kind of context, whatever phrase kind of comes first in the to phrasing, and there will always be a blank to blank, that's going to be in your numerator. You can kind of think of the word to as being the fraction bar, and then that's going to be in the denominator. So 21 apples to 14 oranges. Now, you're going to see that I really like to put units in my fractions. And it takes longer because I got to write stuff out and it's kind of annoying, but it really keeps track of things nicely. Now, what we want is we want this ratio in simplest form. This is the ratio 21 to 14, but we can reduce this because it's a fraction, right? Both the numerator and the denominator are easily divisible by 7, right? So just like putting a fraction in its simplest form, we can divide both of these. Again, I'm going to kind of carry along these units, 3 apples, 2 oranges, right? And that's our simplest form, at least of the ratio in terms of a fraction. Very often what we like to do is then we like to say 3 apples to 2 oranges. Or you could say 3 apples per 2 oranges. That word is very, very important. And again, it's a very simple idea, right? For every 2 oranges, we're going to have another 3 apples, and then another 2 oranges, and another 3 apples. And that's the idea of sort of scaling up and scaling down this ratio. In fact, one might say that in this case, we took this ratio and we scaled it down by a factor of 7 to get the simplest ratio. Now let's take a look at letter B. A smaller fruit basket has the same ratio of apples to oranges as the large fruit basket. If it has 10 oranges in it, how many apples does it have? All right, fantastic. Now, what I'm going to do is I'm going to actually use this simplest ratio, and I'm going to kind of write it in fraction form. All right, so I've got 3 apples to 2 oranges. Now, I'm going to have an equivalent ratio over here. What do I know? Well, I know that it's got 10 oranges, right? What I want is an equivalent fraction to 3/2 that's got a 10 in the denominator. Well, what do we need to scale by? We need to scale by a factor of 5, right? Because to go from 2 to 10, we multiply by 5. So to go from 3 to what? We multiply by 5, and that will be 15 apples. And that's our answer, right? And it's really that easy. It's why representing ratios in fraction form is so critical. You can literally read the ratio. 3 apples, always read the fraction bar as per. 3 apples per 2 oranges. All right, it's really great in that sense, right? You can get a feel for what's going on. Every 2 oranges, we have 3 apples. So if we've got 10 oranges, we have 15 apples. Let's keep reviewing some important ideas involving ratios. All right, scaling a ratio to solve problems. Now, we already saw this in the last exercise, and it's really what ratios are all about. All right, but let's take a look at exercise number 2. The ratio of cats to dogs at a pet shelter is 5:2. Answer the following questions. All right. Now, it was everything in my ability to not just read that as 5:2, okay? So literally, we can show ratios with this strange colon notation. And it's going to sound a little bit weird right now because one of the numbers is the number 2 in it. But literally, when you see something like this, right? Cats to dogs, the colon is just the word 2. Why we don't just always say 5:2, I don't know. You know, I mean, mathematicians are renowned for taking words that are commonly used and replacing them with symbols that don't make any sense, like replacing the word 2 with a colon. Who knows? Anyway, but we do see ratios a lot of times in that form. Let me kind of get rid of this so we have some room to write. All right, so what we want to do is, based on that, we want to answer the following questions. So letter A, fill in the following blanks. And I'd like you to do that now. Just take a few minutes, or not a few minutes, but a few seconds, and try to fill that out. But be careful and look at that ratio statement again. All right, now be careful, because you might be tempted to put a 5 here and a 2 here, but it's actually the opposite way around, right? It says the ratio of cats to dogs at a pet shelter is 5:2, and that means for every 5 cats there are 2 dogs, or for every 2 dogs there are 5 cats. And that's in fact the way that sentence is written. Now let's take a look at letter B. If there are 12 dogs, then how many cats are there? Show or explain how you arrived at your answer. All right, well, let's do this one together, and then we'll have you do C on your own. Now, just like we did before, I like to work in these cases with equivalent fractions, all right? Because then we literally are like looking at that scaling, all right? So what I might do is I might say, okay, for every 2 dogs, we have 5 cats, right? And now we know that there are 12 dogs. So to go from 2 to 12, we're going to have to multiply by 6. We need to do the same kind of scaling in the denominator in order to have equivalent fractions. And in that case, what we end up having is 30 cats. Equivalent fractions make this process so easy and so understandable because we've been writing equivalent fractions by, multiplying the numerator and denominator, or sometimes simplifying fractions into equivalent fractions by dividing numerator and denominator. Let's take a look at letter C, which I'm going to want you to do on your own. Letter C. If there are 45 cats at the shelter, how many dogs are there? Show or explain how you arrived at your answer. All right, fantastic. Pause the video now and see if you can figure out how many dogs there are. Now, you might wonder in this case, when I use that 2 to 5 ratio, or that 5:2 ratio, depending on how you want to think about it, which way should I set up the fraction, to figure out that missing portion? And the answer is it doesn't really matter. But it's extremely helpful, again, to keep track of those units. So remember, for every 2 dogs, I've got 5 cats, and I know that I've got 45 cats. So, this case, maybe I'll do it this way. 2 dogs to 5 cats, right? 45 cats, right? I'm going to multiply by 9 to scale from 5 up to 45. I now have to multiply by 9 in this case, and that's going to give me 18 dogs. All right. Now, our final question in this particular exercise is more one that I just kind of want you to think about and see what you can write down. Letter D. Given this ratio, explain why there could not be 7 dogs at this shelter. All right, so I'd like you to think about this. Let me just write down right here. Remember, our ratio is 5 cats to 2 dogs. Why couldn't there be 7? Think about that. Pause the video. All right, well, it's pretty much this simple, right? This ratio is as simplified as it can get, right? So it's not 6 cats to 2 dogs, it's 5 cats to 2 dogs. Now, if you think about starting to scale this, right? If we scaled it by a factor of 2, we'd have 10 cats to 4 dogs. Then we would have 15 cats to 6 dogs. And then we'd have, 20 cats. Bye-bye, e-math instruction. Get out of there. No, you're not going to go. Must be locked. 20 cats to 8 dogs, right? Now, notice we have completely missed the 7-dog scenario. And the reason why is that 7 isn't an integer multiple of 2. Now, if we could somehow have fractional cats or fractional dogs, then we could actually get there. But the reason in this case why we couldn't have 7 dogs is that 7 is not a multiple of 2. So maybe I'll just tuck that in right here. Letter D, 7 is not a multiple, of 2. All right, great. So today, what we're thinking about, what we're working with is just the simple idea of a ratio, the ways to use fractions to think about ratios, and scaling ratios, mostly upward, in order to find missing pieces of equivalent ratios. So let's keep going on. Let's talk about rates. Rates are a very, very closely connected idea to ratios. In fact, one could claim that they're almost indistinguishable. But specifically what we want to think about and talk about next are what are called unit rates. A unit rate is simply a ratio where the amount of one quantity is given per a single unit of the other quantity. So miles per 1 hour, or inches per 1 foot, or grams per 1 cubic centimeter. So like in the last exercise, we had, 5 cats to 2 dogs. So that's not a unit rate because neither one of those is in terms of 1 unit. So the whole point of a unit rate is the per 1 unit. So let's take a look at an example of this in terms of recipes, which are a great example of things where ratios come up, because oftentimes when you when you think about a recipe, you might need to make that recipe larger or smaller, depending on the number of people that you're serving, right? And you're doing that by scaling. So let's take a look at exercise number 3. A cake recipe calls for 4 cups of flour and 2 cups of sugar. Letter A asks us to express the unit rate of cups of flour per cups of sugar. All right, great. So what I'd like to do when I'm thinking about unit rates is I want to set up my ratio, all right, using the numbers that I'm given, all right, and just kind of take a look at it. All right, so what I'm looking for is the unit rate of cups of flour per cups of sugar. The first thing will be in the numerator, per is the fraction bar, and the second thing is in the denominator. So I've got, let me bring this up to the top, I've got 4 cups of flour per, literally, I want you to think about the fraction bar as being the word per, 2 cups of sugar. Now, remember what we talked about in terms of a unit rate, right? A unit rate is how many of one thing per a single unit of another thing. So we really don't want 2 cups of sugar down here. What we really want is we want 1 cup of sugar. Now, of course, we can do that by simply simplifying this fraction by dividing both the numerator and the denominator by the number 2. So we're scaling this ratio down so the denominator simply has a unit of 1. 2 cups flour per 1 cup sugar. And if I were to write this without the fraction bar, I would say 2 cups of flour per, watch me omit the number 1, per cup of sugar, right? Because the number 1 there is implied. Let me just bring this up a little bit on the screen, right? 2 cups of flour per cup of sugar. All right, makes sense. All right, well, so then once I've got this unit rate, it's great because if I have like 10 cups of sugar, I can say, well, then I'll need 20 cups of flour, right? But let's look at a sort of trickier scenario. Let's kind of flip this ratio. Let's take a look at letter B. Express the unit rate of cups of sugar per cup of flour. All right, this is a little bit trickier, right? So what will I have now? Now I'm going to have 2 cups, let me get rid of my pointer, 2 cups of sugar per 4 cups of flour. All right, and that's a little bit trickier, right? Because I really do want 1 down here. I do want a 1 down there, all right? Now, how do I get it? Well, I divide it by 4. Now, that becomes trickier because 2 divided by 4 is a little trickier than 4 divided by 2. And yet, remember, division and fractions, right? Division and fractions are essentially equivalent. Not essentially, they are equivalent. I shouldn't equivocate. All right, division and fractions are the same thing. So the great thing is, now in the numerator what I have is I've got 2/4 cup of sugar to 1 cup of flour. And as we all should feel very, very comfortable with, 2/4 is equivalent to 1/2, right? So I'm now going to get 1/2 cup of sugar per cup of flour. And again, I like that ratio because then if for some reason I'm saying to myself, well, I've got 6 cups of flour, how many cups of sugar do I need? Well, I only need 1/2 cup of sugar per cup of flour, so if I have 6 cups of flour, I'll need only 3 cups of sugar, right? That unit rate helps me in terms of thinking about how I would scale these recipes, all right? Now, at the end of the day, how do you find a unit rate? It's very simple. You take a ratio and you divide the numerator by the denominator. Now that's literally what a fraction is. So when I set this up as 2 cups sugar divided by 4 cups of flour, I really should be able to just look at this and say, well, 2/4 is the unit rate, 1/2. I shouldn't really have to kind of go through this sort of manipulation. All right, so at the end of the day, a unit rate's quite easy because all you're doing is dividing the numerator by the denominator. And once you do that, then it will always be per 1 of the denominator. So let's keep that in mind as we move forward with unit rates. In fact, I bet we'll see one in the next problem. Exercise number 4. A person is walking at a rate of 9 feet every 4 seconds. Letter A, find their speed, i.e. the rate the distance they travel per 1 second. Speed is undoubtedly one of the most important ratios that we deal with all the time, right? So speed is simply the ratio of how far you've traveled to how long you've traveled, right? So in this case, the speed is 9 feet per 4 seconds. But I want this as a unit rate. I want this as feet per second. So what I'm literally now doing is dividing 9 by 4. Let me do that with a little long division, right? So now maybe over here, it's going to be a little bit ugly with decimals, but that's okay. Let me do 9 feet divided by 4 seconds. That's going to be 2, 8, 1.0. That's going to be 2, 8, 2, 0, as I drop another 0, 5, and that looks to be it. So my unit rate now is 2.25 feet per second. Right? All a unit rate ever is the numerator divided by the denominator in a ratio. Right? And again, in this case, I could have actually possibly even said, well, 9/4, right, as a mixed fraction, that would be 2 1/4. Hopefully that looks familiar, 2.25. So maybe I could have even just left it in sort of mixed number form. I don't think I would want to leave it as 9/4 of a foot per second. That's a little bit unuseful. Let's take a look at letter B now. Given the rate in A, how far would this person travel in 14 seconds? All right, well, see if you can use this unit rate, 2.25 feet per second, to figure out how far a person would travel in 14 seconds. All right, well, the whole point of a unit rate, right, feet per second, is so that I can now actually multiply by the time in order to get the distance. You can really see this, by the way, in the units, and I would encourage you to think about units as you go. And here's what I mean. Really what we have is 2.25 feet per 1 second, and I'm going to multiply by 14 seconds. Now, think about like when you've multiplied fractions before and how things cancel. The same thing really happens with units. This is truly a numerator. If you want to kind of think about it as a fraction, you can think about it that way. And the great thing is now 2.25 feet per 1 second, you can really kind of think about these seconds as canceling and giving you a distance in terms of feet. Now, in order to figure that out, I've got to do a little bit of multiplication by hand, or if your teacher allows you to, you could certainly do some multiplication using your calculator. But I'm going to do it by hand here, bring the board up a little bit so we have a little bit of room. All right, 0, 2, 8, 10, 1, 8, 9, 5, 2, 2. Let me just take a look at that, 28, 10. Okay, 0, 5, 1. And 2 decimal places. So 31.5 feet. All right, that's it. And again, it's one of the great things about having a unit rate, something per 1 of something else. Kind of great. All right, let's move on and take a look at our last problem of the day. Exercise number 5. Kirk is reading a book and found that after 5 days, he had read 180 pages. At what rate is Kirk reading the book in units of pages per day? All right, should be pretty easy now. Why don't you go ahead, pause the video, and see if you can answer letter A. All right, here we go. At what rate is Kirk reading the book in terms of units of pages per day? Well, we're really talking about that ratio of 180 pages per 5 days. So to get the unit rate, what we need to do is we need to divide that numerator of 180 pages by the denominator, 5 days. Let me just do that really quick. I'm leaving out the narrative here, but it looks like 36 pages per day. All right. Awesome. Kirk's zipping along at 36 pages per day, which isn't that fast, but he doesn't have a lot of time, okay? Let's take a look at letter B. If the book is 765 pages long, how many days will it take him to read the book at the rate you found in A? All right. Well, see if you can do it. Take that rate, and see if you can figure out how many days it's going to take Kirk to finish this. And spoiler alert, the answer is going to have a decimal in it. All right, pause the video now, see what you get. All right, well here, it's simply division. We're literally thinking about it. It's sort of like if you took this 765, right, and you took out 36 pages, that would be a day. 36 pages, that would be a day. 36 pages, that would be a day. You get the point. You know, the point here is I'm trying to figure out how many times 36 goes into 765. So that's division. And in fact, right, we're going to do a little long division right now. 765 divided by 36. 36 will go into 76 two times, and that'll be 72. Subtract there, we get 45. 36 will go into 45 one time. All right. I don't know where 35 came from. I just so desperately wanted it to be 35 and not 36. All right, I'll subtract there, and I'll have 9. Now I'm going to bring in some decimals here. So drop that down. We get 90. That's going to be 2 again. All right, which will be 72. When I subtract here, I'll have 18. Tack on another 0. Sorry, we're running out of space here. Let me bring it up. I think that's 5. Let me just make sure. 15, 18. Oh yeah, there we go. So it'll take 21.25 days. All right, that's it. So let's wrap this lesson up a bit. We saw a lot today, you know, because we had a lot to review in terms of ratios. Right? So the big piece, right, is that ratios compare two quantities. How much of this quantity per how much of this quantity. Ratios can then be scaled upwards with multiplication or downwards with division to get equivalent ratios and to answer all sorts of interesting questions. Finally, we have a very closely related idea, which is a unit rate. And a unit rate we get when we expressly have a ratio where one quantity is given per 1 unit of another quantity. We can always find the value of a unit rate by setting up a ratio given the information that we're told in the problem, and then dividing the numerator by the denominator. And that gives us something per 1 unit of something else. All right, we're going to be using these ideas throughout this unit, given that this unit is all about ratios. For now, I'd like to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.